In this video, we're going to talk about solving two-step equations. Okay, luckily the steps that we learned in one-step equations are essentially the same. We just have to make sure that we're doing them in the correct order. And I'm going to give you a couple different ways to think about this, and you kind of go with whatever seems to work best for you. Okay, so when you have an expression and you have to evaluate it, okay, we follow order of operations, which we often think about as PEMDAS. Okay, parentheses, exponents, multiplication, division together, addition and subtraction together. Okay, when we have an equation, okay, we're working backwards. So essentially, when we're solving an equation, you can kind of think of it as SADMAP. Now, really, the exponent won't be there. So you don't have to worry about that. But that means we take care of any subtraction or addition first, then any division or multiplication. And lastly, this doesn't often happen, but those parentheses. Okay. So we're still going to identify what numbers are on the same side as the variable. Sometimes our variable's on the left side, sometimes it's on the right, but wherever the variable is, those two numbers now are the numbers that we need to get rid of. Okay, and because we're doing subtraction, addition first, okay, that's the constant. Okay, and another way to think about it is when you have those two numbers, one of them is going to be like really stuck to your variable. Can't touch that one yet. Okay, that's that multiplication or division. It's really stuck to the variable. You got to get rid of the other thing first. We have to get rid of that constant. Okay, so that's where we're going to either add or subtract to make that constant become 0. Make sure you do the same thing to both sides. You're going to bring down what's left. But now it's not just going to be an x. You might have, a 2x or an x over 7. There's going to be something else there with the x, but you're still going to bring it down. Okay, and then finally, you're going to just have a one-step equation at that point, and you're going to take care of that multiplication division using that inverse operation. Okay, so let's try a couple of these together. So we have 3x plus 7 equal to -5. Constant first, or if you want to think about it, that 3 is really stuck to that x right now, so I can't touch it yet. Okay, but between the 3 and the 7, which are the numbers that are on the same side of our x, we need to get rid of that 7 first. So I'm going to draw my wall. And the way we get rid of a plus 7 is by subtracting 7. Whatever you do to one side, you do to the other side. I can cross off my 7 because 7 minus 7 is 0. And now, instead of just bringing down that x, I am bringing down that 3x. So that comes down on this side. I continue to have my equal sign along my wall. And -5 minus 7 is -12. Oops. -5 minus 7, -12. And now we have to get rid of that 3. I see multiplication, which means I need to divide. So I'm going to divide both sides by 3. 3 divided by 3 is 1. So we get x equals, and -12 divided by 3 is a -4. For the check, we are going to rewrite the question. We are going to plug in the answer we got. So we think the answer is -4. And because that 3 and that x are squished together, I have to make sure I'm showing that that's being multiplied. And we want to know, does 3 times -4 plus 7 equal -5? And now my check's a little bit longer because it is a two-step equation. So when I do my check, I am going to follow order of operations, which means I'm going to do my multiplying first. So 3 times -4 is -12. And now I can do -12 plus 7. The signs are different. Subtract, take the sign of the bigger number. You get -5 equal to -5. So that means my answer of x equals -4 should be correct. I'm going to jump over one to that x over 2 minus 3 equals 1, because I want to do a division one. I'm going to draw my wall. The numbers that we have to get rid of are the 2 and the 3 because they are on the same side of our x. and constants first. We have to get rid of that minus 3. We are going to do so by adding 3. I can cross that off because it equals 0. Now I'm going to bring down my x over 2. I have my equal sign, and 1 plus 3 is 4. And now to get rid of my division, I can multiply both sides by 2. Cross that off because that equals 1, because it's really 2 over 1. So number on top, number on bottom, they make 1. And we get x equals 8. And for my check, I'm going to rewrite it. I think the answer is 8. So I'm going to plug that in for my x. 8 divided by 2 comes first, our multiplication division. So that's 4. And does 4 minus 3 equal 1? Indeed, it does. So our answer is x equals 8. Okay, I'd like you to pause the video and try those other two along the top row. Okay, the one I skipped and then the one at the end of the row. Okay, use those two that we just did together as an example. And when you think you are good, okay, including the check, okay, press play so that you can see how you did. Okay, for this one, we have to get rid of minus 8. So we add 8 because that's 0. We get 2n equals negative 6. Signs are different, subtract. Take the sign of the bigger number. Then we can divide by 2. And n equals negative 3. For my check, 2n minus 8 equals negative 14. So I believe the answer is negative 3. I want to know, does that equal negative 14? My multiplication gives me negative 6. And negative 6 minus 8, the signs are the same. It's a negative 6 and a negative 8 that we're putting together. So when the signs are the same, we add and keep the same sign. We get negative 14 equals negative 14, which means my answer of negative 3 is correct. And on this one, draw my wall. The 3 is what we need to get rid of first. So to make that 0, we are going to subtract. So I can cross it off because it's 0. We get w over 4 equals 5. And now I'm going to multiply both sides by 4. And w should equal 20. Rewrite my question for my check. I think the answer is 20. Put that there. Division first, so 20 divided by 4 is 5. So it becomes 3 plus 5, which does equal 8. Okay. Oh, sorry. We have some more questions at the bottom, which are a little tougher. So you have to be careful with these. And really, it involves some negative signs, which is what makes these harder. So if you need to, circle, highlight, do something to notice that negative sign, okay, that should hopefully help here. So we have a 7 and a 4, well, really, I guess a negative 4 that we have to get rid of on this bottom one. I'm going to start by getting rid of that 7. That hasn't changed. We have to get rid of those constants first. So I'm going to subtract the 7 to make it 0. But this is where we have to be careful because it's not just a 4y we are bringing down. It is a negative 4y. Okay, and if you lose that negative, you're going to get the wrong answer. So negative 4y equals positive 12. And to get rid of that negative 4 that's being multiplied, we must divide by negative 4. Some of you guys are still making that mistake. Whatever number is with the variable, when it comes to that division step, you have to divide by that number. And we end up with y equals a negative 3. Okay, so rewrite my question. I think the answer is negative 3. multiplication first, and there's a couple ways you can think about this. Okay, I'm going to look at it as this is a -4 times a -3, which would be a +12. And you could also do, if you want to think of it, you would have your 7 minus, and then 4 times -3 would be -12. And that double negative is then going to change into a plus. So those are the two ways to think about that. And we get 19 equals 19. And we're good. This one, I kind of like to call it a 1.5 step equation because the last step is not like a very hard step. Okay, but you have to recognize when this happens. So we have to get rid of that -12 by adding 12 to both sides. But we don't just get an A, we get a negative A. And negative A equals -4. Okay, but we've talked about how we cannot have a negative A, we need it to be a positive A. Okay, so shortcut wise, and you are allowed to do this if you remember, shortcut wise, you are allowed to switch that to a positive A as long as you also change the sign on the other side. If it was a -4, it becomes a +4. If it was a positive number on the other side, you'd make it a negative number. Okay. So you're allowed to just kind of change both the signs if you're trying to make it a positive A. Really, what's happening here is there is that invisible -1 there. And now you're dividing both sides by -1, which makes it your positive A, which also changes that sign. Okay. But if you need to, change the sign of your A, you can switch signs of both sides. Okay, we're going to check 7 minus 4y equals 19. So 7 minus 4, we think the answer is 4. Oh, I don't know where I got 19 from. I was looking at the other question. That's where I got 19 from. I'm rewriting the wrong question. Sorry about that. It would help if I'm looking at the one we just did. So -12 minus A equals -16. We think the answer is 4. So -12 minus 4. Okay, does that equal -16? And on the left side, those signs are the same. We add them together. We keep the same sign. We do get -16 equals -16. 2 more. We got this. Okay. Here, we have to get rid of that 2 and that 9. We're going to start by getting rid of the constant, so subtract 2. But once again, be careful. To highlight, not scribble. We have a minus x over 9. Now, you could bring it down like it is already, where that fraction, that negative's kind of chilling outside that fraction bar. But really with a fraction, that negative could be placed wherever we want it to be. So technically we could put it up on top in the numerator with the x. We could put it down in the denominator with the 9. And often it's kind of weird to stick it down in the denominator, but for the purposes of solving our equation, it actually makes the most sense. So that's what I'm going to do. I'm going to erase that negative sign. Okay, and I'm going to stick it down in the denominator because now it should look like those one-step equations that you did where you had a negative number in your denominator. So we have x over -9 equal to 3. And now we can get rid of that divide by -9 by multiply by -9, which gets it to 1, and x should equal -27. So my helpful tip for this one is to put the negative in the denominator if you have some type of situation like that. Okay, we have 2 minus x over 9 equals 5. We think the answer is -27. We want to know, does that equal 5? I'm going to do that division. So we get 2 minus -27 divided by 9 would be a -3. Ooh, interesting. because 2 minus a negative 3, that double negative becomes a plus. So 2 plus 3 does equal 5. Okay, last one. And this one obviously, well, I should say obviously, hopefully looks a little bit different to you. Okay, so all the other ones, we kind of follow this format of, our x had either multiplication or division, and we had that separate constant. Here, this is different. Okay, so kind of going back to my SADMAP, okay, we said we take care of subtraction, addition, then multiplication, division, and then the last thing would be parentheses. Okay, now when we have a fraction like this, where we have two pieces joined together in either the numerator or the denominator, what's actually happening is there's an invisible set of parentheses there. Because if I want to take this fraction and kind of write it sideways, don't write this down because I'm going to end up erasing it. Okay, but I would write this as w plus 2 divided by 4. We'd have to put that w plus 2 in parentheses to show it's grouped together. Okay, so that's actually going to be the last thing we do. We're not going to touch that numerator yet. In terms of, what's stuck to the w, that 2 in this case is more stuck to the w because it's grouped together in the numerator. So we actually have to do that multiplication division first before those invisible parentheses. So we're going to get rid of that divided by 4 by multiplying both sides by 4 here to make it become 1. Now we're going to bring down that numerator, which is w plus 2. It equals negative 32. And now I can get rid of my plus 2 by subtracting 2. And w equals a negative 34. Stop boxing up all my answers. Okay, so you're probably not going to encounter that often, but I did want to throw that in there just in case. Okay, last little bit check. We have w plus 2 over 4 equal to negative 8. We think the answer is negative 34. So negative 34 plus 2 over 4. Does that equal negative 8? Well, on top, negative 34 plus 2 would be negative 32. Signs are different. Subtract, take the sign of the bigger number. And now negative 8 does indeed equal negative 8. Okay, so for the most part, constants first, then do that remaining one-step equation by doing the inverse operation. Okay, make sure you're using those checks. I know they're annoying, okay, but they really should help you realize when you're making some silly mistakes, either with the equation solving process or with your integer rules.